Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our first lesson on inverse functions and their graphs. In our last lesson, we learned about one-to-one functions, onto functions, and one-to-one correspondences. Today, we will study inverse functions. We will define them and describe the conditions that they need to exist. We will also learn to distinguish an inverse function from an invertible function. Are you ready, students? Then let us begin. If the inverse of f is g, then g is denoted by this form. In this case, f is called invertible. These are the steps in finding the inverse of a function f. First, we must interchange x and y in the formula of f. Then we must solve for y in terms of x. Finally, we write that y equals the inverse of f of x. Given a function f, the inverse of f can be a function if and only if f is 1-to-1. For example, here is the function f of x equals 2x squared. Is the inverse of f also a function? Let us find out together. The domain of f is the set of real numbers. F of 1 equals 2. F of negative 1 also equals 2. This demonstrates that f is not 1-to-1, and therefore the inverse of f is not a real function. Let us do an activity, students. Here are 3 functions. With a partner, determine if the inverse of each is also a function. You can get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us look at the correct answers together. The inverse of function A is found by solving the equation x equals 4y minus 8. First, we divide both sides by 4, giving us x over 4 equals y minus 2. Then the 2 switches signs, leaving us with the final equation y equals x over 4 plus 2. This is a function. The inverse of function B is found the same way. First, both sides are divided by 3, and both sides are solved for their square root. This leaves us with the equation y equals the square root of x over 3. This is not a function. Function C resembles function A, does it not? We can solve it in the same way. However, the end result is y is greater than or equal to x over 4 minus 2. Since function C is not one-to-one, the inverse of function C is not a function. Do you understand, students? Good. Now we will learn about the identity function. The definition of the identity function is function I maps A to A, given by I of x equals x. If f maps A to A and I maps A to A, then I composed with f of x equals x for every real number x. Conversely, f composed with I of x equals f of I of x equals f of x for every real number x. We can use this to determine whether one function is the inverse of another function. Let us look at an example. F of x equals x plus 1 over x plus 2, where x is different from negative 2. G of x equals 1 minus 2x over x minus 1, where x cannot equal 1. F of g of x equals f of 1 minus 2x over x minus 1. This equals x, which equals the identity function I of x. G of f of x equals g of x plus 1 over x plus 2. This equals x, which equals the identity function I of x. Therefore, we can conclude that f and G are inverses of each other. Let us try an activity, students. Here are two functions from our last activity. Using identity functions, prove that f and g are inverses of each other.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to employ identity functions? Let us work through this problem together. First, let us look at f of g of x. This is equal to f of x over 4 plus 2. When we substitute g of x, we are left with the equation 4x minus 8 over 4 plus 2, which we may simplify to x. F of x equals I of x, the identity function. Now, let us verify the relationship in the other direction. G of f of x is equal to g of 4x minus 8. When we substitute f of x, the equation is g of 4 times x over 4 plus 2 minus 8. We can simplify this to x as well. G of x equals I of x, the identity function. Congratulations, students. You have proved that f of x is the inverse of g of x by using the identity function. A function g is said to be an inverse of a function f if and only if g of f of x equals I of x and f of g of x equals I of x. That is all for today. We have learned about the inverses of functions and about identity functions. Until next lesson, thank you, teacher. Thank you, students.